Hey class, this is Miss Norwood. I just wanted to let you know that my three pets are paying very close attention to my videos. There's Pip, Cheyenne, there's my dog Cheyenne, and there's my fat cat Oliver. So don't worry, I'm not teaching to an empty room anymore. So now I'm at home and I set up this little studio and hopefully this is gonna be great. All right, so I'm coming in. All right, so we are going to talk about the equation of an ellipse, okay? So what I want to start off with is something that we learned earlier this year, which is x squared plus y squared equals r squared. Hopefully you recognize that as a circle with a center at, not x, sorry, a circle with center 0, 0, okay? We didn't really have the need in this class to move the circle, but if you wanted to move it off the center, okay, you just subtract like this, and now you have a center of HK. Hold on, I'm just gonna make sure my video's on. I filmed a whole video the other day without it being on. Hold on. Okay, sorry about that. Okay, so this is something you might have seen before in a different class. Okay, so we are going to just change this slightly. We've probably never done this before, but we're just going to go ahead and divide all these by r squared. So you get x minus h squared over r squared plus y minus k squared over r squared equals 1, which is also a circle, okay, with a center at hk. Okay, so the reason that this is a circle is because in the x direction, you go out r, the radius. In the y direction, you go out r, the radius. Since they're the same, you get this perfect circle. So an ellipse is different because this number is going to be different than this number. And this number tells you how wide the ellipse is, and this number tells you how tall it is, okay? So I know we talked a lot about A, B's, and C's before. What's really important in this unit is not that you know what A, B, and C mean, is that you know that this, whatever's under here is x, and whatever underneath here is y. So I am going to write you like two equations down, but really if you keep that in mind, this is going to be really nice. Okay, so the first equation, if you have this, okay, so a squared underneath there, okay, all right. So this number tells you the x direction, this number tells you the y direction. We kind of talked about before how A always is the biggest, so this ellipse would open this way. It would be wider than it is tall simply because this number is the biggest number, okay? If the bigger number was underneath the y instead, like this, okay, then it would be taller. And these all have a center of HK, of course, okay? All right, so I'm going to do a couple of examples, okay? I'm going to erase all this, so just pause it if you still need it, okay? So the first thing I'm going to remind you guys of is the relationship we just learned in the other video, that a squared always equals b squared plus c squared. If you notice, the c doesn't show up in the equation. The foci don't show up in the equation, but you still always have to find them, okay? All right, so our first example is going to be this problem. So I want you guys to write this down. You do need graph paper for this, so go get some if you need it. X minus 5 squared over 4 plus y minus 3 squared over 16 equals 1. Okay, so draw yourself a grid like this. That's your equation, okay? And this is what I want you guys to remember. First thing, find the center, okay? So the center is HK. They're the opposites, just like they were for the parabola, okay? So HK. So go to your graph, 1, 2, 3, 4, 5, 1, 2, 3, and that is the center. You can label it like with a little c if you want to, okay? This number, the square root of this number, tells you how far you go in the x direction. So don't stress about, oh my gosh, is that A or is that B? Don't worry about that. Just in the x direction, go out 2 from the center. So go out 2, go out 2. Okay. In the y direction, you got the square root of this number. Square root of this number is 4. So in the y direction, you go 1, 2, 3, 4, 1, 2, 3, 4. Okay. After you have all of that, now you can go ahead and try to draw the best ellipse you can. So just connect those, kind of do a nice curve, no straight lines. Okay, and that's your ellipse. Okay, now you can go ahead and label it a little bit. The tall side is on the y-axis, so this is a vertex, this is a vertex. The short side are the covertices. Okay, so covertice. Okay, Oliver. My cat's right there. I don't know if you guys can see him. Okay, so now what you want to do is you guys want to find the foci. And here's the thing, the foci are always lined up with the vertices, okay? So if the vertices are this way, the foci are also this way. So the foci are going to be like somewhere in here, okay? To find them, you have to use this equation. So again, don't worry about the letters so much as the big one. This is the biggest number. This is always the biggest, okay? The biggest number is 16. So 16 equals, and then this is the not big a number, and then that'll help you find the distance to the foci. So you subtract, okay, square root, okay, and I do want you guys to reduce that. So the distance, this is the distance, okay, from the center, okay, to each focus. All right, so I don't want you guys to use a calculator. I want you to do some approximating. We're going to approximate how big this is. I actually prefer to use the unreduced version because it's a little bit easier. Root 12 is in between root 16 and root 9. So it's in between, okay, 3 and 4. And it's pretty equidistant between them, but it's a little closer to 9. So I'm going to guess that root 12 is like 3.4-ish, okay? So that means from the center, go 1, 2, 3.4-ish, and that is your focus. 1, 2, 3.4-ish, and that is your focus, okay? So this is my rule. If a point falls right on a nice even spot, like this is clearly 7, 3, then you don't need to label it. But if it falls on a weird like decimal root thing, you guys have to tell me the exact x and y coordinate. Okay, so for this point right here, you can count over 1, 2, 3, 4, 5. So this has an x value of 5. This distance right here, I need the exact height, not the approximate height. Okay, so I don't really know how far this is, but I know that this is 2 root 3 from the center. And I know the center has a height of 3. So it's 3 plus 2 root 3 more. Okay. To get to this one, again, it's over 5. This is a distance of 2 root 3, but this is 2 root 3 below the center, so this is going to be 3 minus 2 root 3. Okay. So when you do your homework, this is what you should have. This is what it should look like. The vertices, the covertices labeled, the foci labeled. At any point that's not on an exact grid spot, you need to write the coordinate for me, okay? All right, we're going to do one more example. You have a choice. You can see the example, try to do it yourself, and then show the video to see if you did it right, or you can just listen to me explain it one more time, okay? All right, so I'm going to erase all this. So rewrite this, I shouldn't have erased that. Okay, and the example we're gonna do this time is x plus 1 squared over 9 plus y plus 3 squared over 5 equals 1. Okay, so you know it's an ellipse, what it looks like in this form. This always equals 1. You always have x first, then y. And remember, the first thing you always want to do is find the center. So the center is the opposite of x, the opposite of y. So just go ahead on your graph and plot -1, -3. That's my center. Okay. Underneath the x is a 9, so I go 3 in each direction. 1, 2, 3 in the x direction, 1, 2, 3 in the x direction. Underneath the y is the root 5. Root 5 is just a little bigger than root 4, which of course is 2. So root 5 is like 2.2-ish. So in the y direction, 1, 2.2-ish, 1, 2.2-ish. and then just do your best. As soon as you have those points, you can go ahead and draw an ellipse. Okay. Now I want you guys to label which ones are the vertices and which ones are the co-vertices. So remember, the vertices are the longer ones. So it's longer this way. So vertice, vertice, co-vertice, co-vertice. Okay. So the thing you have to add to the picture now are the foci. And remember, the foci are always in the same direction as the vertices. So if the vertices run this way, the foci are going to be here. Okay. To find them, use this equation. Okay. Out of these two numbers, 9 is obviously the biggest one, so 9 equals 5 plus c squared, 4 equals c squared, 2 equals c. That is the distance from the center to the foci, okay? So that means that I am going to go out 2 in the long direction, foci, 2 out in the long direction, foci. Okay, I do not need to label these 4 points because I can see clearly what they are. 2, -3, 1, -3, -1, -3, etc. But these two, you guys have to give me exact coordinates for those. Okay, so the co-vertex has an x value of -1. This distance is √5. So from this point, add √5 to get there. So that's -3 plus √5. This is also √5, but it's below it. So here it's -1, and then it's -3 minus √5. Okay, so I want you guys to try a couple of these in homework. Email me if you have any questions, and I will do my best to answer those. All right, take care, you guys. See you tomorrow. Bye.